this lecture, we are going to understand what is a set in mathematics. A set is a well-defined collection of objects. So a set is a well-defined collection of objects. Suppose if I ask you to tell me the five most renowned mathematician in the world, like example first, five most renowned mathematician in the world. So this is going to be vary person to person. Like if person one given five names, like name one, name two, name three, name four, name five, and person two, person second given three names, one, two, three, four, and five. According to person one and person two, the mathematicians' names would be vary. So that's why we are trying to find out the meaning of a well-defined collection of objects. What is means of a well-defined? So, for example, five most renowned mathematicians in the world, according to two person, like first person given a different five names and the second person given a different five names, or maybe name third or second person will going to match. Kindly, what we can say about it, like a collection of five most renowned mathematicians of the world is not a well defined, because the criterion for determining a mathematicians as a most renowned may vary from person to person. So that's why it is not a well defined collection. So what we can say, this is not a well defined collections of mathematicians. Okay, before that, we are going to talk about the three important points about sets. Three important points about sets. First one is objects, elements, and members. Members of a set are synonymous terms. Synonymous terms. And the second thing, what we need to remember, sets are usually denoted. Sets are usually denoted by capital letters like A, B, C, X, Y, Z, etc. And third thing, what we need to remember about sets, the elements of sets are represented by small letters. The elements of a sets are represented by small letters. Represented by small letters like A, B, C, X, Y, Z, etc. Now we are going to see some examples like example first. A belongs to A. The symbol, this epsilon here means is belongs to, and this symbol is a Greek symbol. Greek symbols, which we call it as a epsilon. Epsilon. So this symbol is Greek symbol epsilon. And second example is example 2. A doesn't belongs to A. Here epsilon, which is cancelled, like that symbol is called doesn't belongs to. Yes. So these are symbols which we are going to use in further lectures. So that's why here I'm just trying to clear it out so that it would be easy for you to understand the symbols and their meanings. Let me take some more examples. Like example 3. Like we have a set V, which is a set of vowels in English alphabets. Like in English alphabets, we have a vowel A, E, I, O, U. And now we are going to see the symbol's meaning. Like if I write like that, A belongs to V, A belongs to V, it means that we have a symbol in that set, and A doesn't belongs to V, it means that we doesn't have that symbol in our V set, in vowel set. Okay, one more example is like for example, example 4, prime factors of 30. Prime factors of 30. Yes. So what we can write here, like suppose I'm taking the set as a Z, and inside that we know the prime factor of 30 is 2, 3, 5. And so this is a set, and if I write like that, 3 belongs to 3 belongs to 30. Yes, it is true. And if I write like 15 belongs to 30, but here we don't have that 15 as a prime factor, so we can write like that, like 15 doesn't belongs to 30. Few more examples of sets used particularly in mathematics. So first, capital N symbols we use to represent the set of all natural numbers. Z symbol, capital Z, we use to represent the set of all integers. Capital Q symbol, we use to represent the set of all rational numbers. Capital R symbol, we use to represent the set of all real numbers. If instead of Z I write Z plus, these symbols represent the set of all positive integers. And at the place of Q, if I write Q plus, these symbols represent the set of all positive rational numbers. And if I write at the place of R plus, these symbols represent the set of all positive real numbers. So these are the symbols which we use in sets. So in further lectures, I'm going to use all these symbols for the sets. So in the next lecture, we are going to see about how many methods are there for representing a set.